So in the last class, so after this we have the first cascading of blocks. Directly we can cascade those two blocks G1 and G1 into G2. Okay, so these two blocks can be directly matched into a single block. Next, when they are connected in parallel, so you will get G1 plus G2. So if we have summing point, we want to move summing point after the block, an additional block is added whose gain value is this one. If I want to move on ahead of this after this one, again we have to add one more block at the summing point whose value is G. Okay, is it clear? Next, if I want to move a summing point ahead of this block, in that case, again we have to add one more block, but whose gain value is 1 by G. In forward direction, we have to add G. In reverse direction, we have to add 1 by G. So if I want to move this summing point, okay. So kindly remember this one. So if we want to move this summing point after this block, in that case, we have to add G, okay. So block gain is added, G is added at the summing point. Similarly, if we want to move summing point ahead of this block, in that case, a block 1 by G is added. Okay, so up to this part we have finished in the last class. Now the continuation, again takeoff point. If we want to move the takeoff point after this block, okay. So if we want to move takeoff point after this block, okay. So if we observe here, takeoff point means output is same as input. Here input is x1, output is x1. Okay, whereas here the input is also x1 at the takeoff point. This is takeoff point. So whatever be the input, the same output goes through all branches. The same input goes through all the branches. Okay. Now, so here the input is x1. So final output becomes x1 into multiplied with gain. Input multiplied with gain, you will get output. So in this case, the output is x1 G1 and one more output is x1. This is also output. So that's why I have shown arrow in this direction. So input is x1. Now, if we observe, input is x1, output must be x1 and output is x1 into G1. There are two outputs, x1 and now if I want to move this takeoff point after this block, just I have moved after this block. Now, so if we observe the input is x1, output is, there is no problem. Here in this case, that is x1 into G1. That is output. So at the takeoff point, the same output, so will travel in this direction, x1 into G. So x1 into G here. Okay. So if x1 into G, if we consider as input, and output is fixed, that is x1. So to get this output, the transfer function must be, okay. So that is output by input, you get 1 by G. So 1 by G block is added if we want to move, a takeoff point after this block. Is it clear? So output and input, they are not going to change. But if I want to move a takeoff point after a block, so in that case, a block 1 by G is added at the takeoff point. That we have to remember. Previously, in forward direction, while moving a summing point, that is block G is added at the summing point. But in case of takeoff point, block 1 by G is added. Okay, so get confused here. So try to remember. So while moving a summing point, a block G is added. While moving a takeoff point, so block 1 by G is added at the takeoff point. Okay. So same thing. So in here it is. If we want to move a takeoff point ahead of the block, so ahead of the block means, so I want to move this takeoff point in this direction. So here the input and output are fixed. So input is x1, output is the x1 into G. Here it is also x1 into G. So these are the outputs. So again, these input and output values that remains same. Now, if I want to move this takeoff point ahead of this one, so in this case, okay, so now input to the block is x1 because takeoff point this is. So here it is also x1. So output is fixed x1 into G. Input is x1. So the block gain is G. Okay. Here input is G. Input is x1. Gain is G. Output is x1 into G. So from this, so we can say that if we want to move a takeoff point ahead of the block, in that case, a block G is added at the takeoff point. That is the rule. Okay. So we have to remember these, at least these four. Okay, these six, not four, previously two, cascading and parallel connection. So if we can able to remember all these six formulas or six rules, okay, we can solve a complex network into, we can reduce into a complex network into a single network. Okay, just a minute. Okay, so please kindly note down these formulas. The next one is elimination of a feedback loop. So elimination of feedback loop means, just note down this example, these formulas. Okay, eliminating a feedback. So this is the formula given. So this is called as forward path gain. G is called forward path gain in this direction. Okay, so this is called forward path input to output. Whereas the reverse direction, the feedback is always in the reverse direction. So this becomes a loop. This is called a loop or a closed path. Okay. So how to eliminate this kind of loops? Using this formula, we can eliminate. So G by 1 plus GH. If it is a negative feedback, so you will get positive sign. If it is a positive feedback, you will get negative sign. That we have to remember that this we have already derived. This formula we have already derived while discussing about the effect of feedback on overall gain. Okay, that we have discussed. Okay, so I don't want to derive the same formula and try to remember that formula. This is very important to eliminate a feedback loop. That means only this is the feedback loop H. I want to eliminate this path, entire path. So to eliminate this block or feedback loop, so formula is the forward path gain, that is G. G or any value, whatever it may be the value, G by 1 plus G into H. Okay. So this is the formula given. The feedback value is H. So G is forward path gain. So overall, the block can be eliminated and that can be represented with a single block whose transfer function is G by 1 plus GH. This is very important formula up to 7. Okay, if you can remember this, so you can solve, we can reduce any complex block diagram into a single block. So next, some more formulas are also there. You can also just by looking at this, we can find out, we can split. So interchange the summing points. We can interchange the summing points. Simply, the total value is not going to change. Okay, this summing point can be kept here and this summing point can be moved here. So similarly, splitting a summing point. So here the total 3 signals are adding. So that can be split into 2 summing points. So we can split the summing points. We can interchange the summing points. Just note down these formulas. Some more formulas are also there. So they are okay. You can able to remember, otherwise they are not much important. Still 237 is adding someone to disturbing the class. Okay. So have you written? So summing, interchanging of summing point, splitting summing point. Now we are going to solve one example based on these formulas. Very, very important formulas these are. So once we can able to remember up to 6 or 7 formulas, so we can solve any complex example. So these are the rules to reduce a complex block diagram. The block diagram is given. Block diagram means it is a representative control system consists of number of components. Each and every component is represented with a block. So connecting all these, okay, it forms a block diagram. So reducing that block diagram into a single block, that is called block diagram reduction technique. So for this, to reduce these blocks, okay, so to reduce or to obtain a single block or to obtain a transfer function model of this complex control system, Okay, we have to apply block diagram reduction rules. Those are the rules just now what we have discussed. Those are the 7 basic important rules. So some more rules are also there. So 3 to 4 additional rules are also there. Okay, so very rarely they are used. Okay, they are applied for our problems. Okay, so you can discuss later. These are the steps to be followed while reducing block diagram. The first step, we have to check the blocks connected in series and simplify. The first step is given a complex block diagram. The first step we are going to check, that is any block. Okay, blocks connected in series, so one after the other. Okay, that can be, that means cascade connection, not the series connections simply. That is a cascade connection. So we can simply first merge those blocks. If two blocks are connected in cascade, G1, G2, G3, G4 and all, we can directly merge into a single block whose gain value is G1 into G2 into G3 into G4. So all these, if they are connected in cascade, okay, there should not be any branch or block in between those blocks. Only cascade connection. Okay, so directly we can merge those blocks into a single block whose gain value is G1 into G2 into and so on. Okay, that is first step. Second step, we have to follow if there is any parallel connections. Parallel connection means, so before the block there should be a takeoff point. After the block, so after the block we have to get uh, a summing point. So that is called parallel connection. So like this is called parallel connection. So before the block, a takeoff point. After these blocks, we'll have some one summing point. So in this is called parallel connection. So observe for this kind of blocks. Okay, if there is any blocks connected in parallel, so the second step we have to apply this rule and merge those blocks into single block. So finally you will get G1 plus G2 or G1 minus G2. For example, n number of blocks are connected in parallel. In that case, we have to add G1 plus G2 and so on up to Gn. Okay. The second step, we have to reduce the blocks. Okay. So third step is check for the blocks connected in feedback loop and simplify. So the third step, we have to eliminate feedback loops. If there is any feedback, okay, try to eliminate that feedback loops. So feedback means, so just by applying the formula G by 1 plus GH, if there is a negative feedback, you will get positive sign, 1 G by 1 plus GH. If it is a positive feedback, that is G by 1 minus GH, you will get as an answer. Okay. So eliminating feedback means that is replaced by G by 1 plus GH. Okay. And unless otherwise specified, most of the cases you will have negative feedback. So you have to use the formula G by 1 plus GH only. Okay. The next step. Fourth rule, if there is any difficulty with taking takeoff point, if there is a difficulty with the takeoff point while simplifying, shift it towards right. So move the takeoff point after a block. Okay. So first merging the series connections, next parallel connections, next eliminating blocks, while eliminating while eliminating feedback loops, if there is any difficulty, okay, using takeoff point, if there is a takeoff point in between two blocks, in that case, how to simplify that one? So the first step is moving takeoff point after a block. So after a block means we can add those two blocks. Okay, applying. So if there is any block, okay, so for example, if there is block something G1, G2, and something like this, okay, a summing point and like this, and a takeoff point is here, okay, and it is connected with some H1, H2, and so on. So if there is any problem, in that case, if we move a takeoff point after this block, so that we can merge these two, we can directly cascade these two blocks, and the final thing becomes feedback for this entire block. So G1 plus G2, that becomes a forward path gain, where this takeoff point, we have moved this takeoff point after this block. That block means in that case 1 by G is added at this takeoff point. So 1 by G into H1 becomes feedback for this forward path. Okay. So let us discuss the same while doing problems. Okay, that is the formula. If there is any difficulty with the takeoff point. Similarly, if there is any difficulty with the summing point, okay, try to shift the summing point towards left ahead of the block. Okay, so try to shift ahead of the block. In that case, 1 by G is added at the summing point. Okay, that we have to remember. Okay, so repeat the above steps till you get the simplified form. So this is the steps to be followed while reducing block diagram. Okay, so try to note down all these steps, and we have to remember that the transfer function present in this single block is the transfer function of the overall block diagram. So finally what we have obtained is nothing but overall transfer function. Transfer function, okay, it is called as overall transfer function. Otherwise, it is a mathematical transfer function model of a control system or that particular block diagram. Okay. So note down this and try to note down this example. Next, note down this example. Consider a block diagram shown in the figure. Let us simplify or reduce this block diagram using block diagram reduction technique or reduction rules. Draw this figure neatly. Okay. So we have to reduce. Just if we can able to remember those first 7 formulas. Okay. We can reduce this complex block diagram into a single block. But it takes a little bit time initially. Once we practice this, within hardly 5 to 10 minutes, we can reduce the entire block diagram into a single block. Just draw this figure. Okay. So once we observe this, the first step, you have to remember that if there is any block if there are any blocks connected in series or cascade connection. So here the block G1 and G2 are connected in series, that we have to observe. So forward path means from input to output. This is called forward path. RS, R of S, that is summing point, one more summing point, again G1 block, G2 block, one more summing point, one more takeoff point, G3 summing point, again takeoff point, G5, again takeoff point, final output is Y of S. Okay, we have to reduce all these blocks. Okay, eliminate all these blocks into a single block. For that, we have to take first rule is merging series connected blocks or cascade connected blocks. That is G1 into G2. Okay, that we have to write yes first. So here it is, rule number 1 we have applied, reducing the block G1 into G2. And rule number 2, so again in the same thing we can reduce, these two are connected. If we observe up to this portion, these two are connected in cascade. Okay, so that is rule 1. And this portion, that is up to this, we can replace with G3 plus G4. They are connected in parallel. Okay, here the sign is positive sign. This is also a positive sign. So G3 is positive, G4 is also positive. Okay, so result we can replace with G3 plus G4. Here this can be replaced with G1 into G2. Okay, the first step, eliminating, first rule, eliminating, reduce, sorry, not eliminating, that is using series, observing the series connected blocks, and similarly second rule, parallel connected blocks. So here I have applied both rules. Rule number 1, that is replaced with G1 G2, applying rule number 2, that is replaced with G3 plus G4. Okay, again we have to redraw the figure, so it takes a little bit time, but try to note down this figure. So I have replaced with G1 and G2. So here that thing is replaced with G3 plus G4. Okay, so note down this figure. We have to represent like this. Step 1, using rule, no need to apply this rule 1. Okay, but cascading blocks G1 and G2. Okay, and eliminating parallel paths G3 and G4. Like that we have to write. Okay, first one is cascading blocks G1 and G2, eliminating parallel paths G3 and G4. So that is the step 1 what we have applied. So in this case R3, that is input. So here I have replaced with G1, G2 and this. Okay, next, note down that figure. The 29 members. Okay, very poor attendance. Okay, so in step 2, now if we observe, this is up to this portion. In this figure, up to this portion, if we observe, so forward path gain is G1, G2, and this is feedback. So we can eliminate feedback H1. Write down here, eliminating feedback H1. Okay. So and we can reduce. So eliminating this is using rule 3, the block G1, G2 and H1. Rule 3 means eliminating feedback H1. So eliminating feedback means G by 1 plus GH. We have to apply the formula G by 1 plus GH. In case of instead of G, here the forward path gain is G1, G2. Okay. So feedback is H1. So now the entire thing I have replaced with just by eliminating this entire portion, and that can be replaced with G1, G2 by 1 plus G1, G2 into H1. Is it clear? So అర్థం చేసుకుంటే మీరు అన్ని చేసేయచ్చు. So just eliminating feedback. So forward path gain is G1, G2, feedback gain is H1. So I want to eliminate this and write it as entire thing I have replaced with G1, G2 by 1 plus G1 plus G1, G2. Okay. So that is eliminating feedback H1. So next, so here this is a takeoff point. So if we move a takeoff point after this block, okay, so we can merge these two blocks, G3 plus G4 into G5. Okay, we can reduce these two. So moving a takeoff point after a block, so a block is added at the takeoff point whose value is 1 by G5. The same thing I have represented here. Okay, so if we move a takeoff point after a block, in that case, a block is added at the takeoff point whose gain value is 1 by G5. Okay, so here, so we have applied two steps. One is eliminating feedback H1 and moving a takeoff point after a block G5. Like that we have to write. Okay, so eliminating feedback H1 and shifting takeoff point after the block G5. So and try to draw this figure. So here I have merged these two blocks. Okay, these two are in cascade. That's why I have represented with H2 by G5. These two are in cascade. We can represent with a single block, that is G5 into G3 plus G4. Okay. So note down that figure. So if you have any doubts, you can raise the doubts immediately. First step, if we have any series connection, reduce them. If there is any second step, if there is any parallel connections, reduce them. Next, third step, if we have any feedback paths, eliminate the feedback paths. Next, if we have any problem with summing points or takeoff points, takeoff point is moved towards right, summing point is moves towards left. Okay, the same formulas I have applied here, same rules. Okay, apply this one. So now if we observe, these two are connected in series. Again, merge this one into a single block. So G5 into G3 plus G4. This becomes G by 1 plus GH. H value is H3. G value is G5 into G3 plus G4. So finally G by 1 plus GH, if we apply the same formula and replace the entire thing with this one. Okay. So in the next block diagram, so if we observe the next block diagram, that is G1 G2 by 1 plus G1 G2 into H1. So here we have merged these two blocks into a single block, and here these two blocks into a single block. So now rule 3, again merging, eliminating feedback. Eliminating this feedback means this entire feedback can be replaced with a single block. That is G value here, this becomes Z, and H3 is negative feedback. So G by 1 plus GH. Now if we observe these two are connected in cascade, again we can merge these two into a single block, and if we observe this is a forward path direction, this becomes the negative feedback direction, so with positive sign. So in this case formula we have to use G by 1 minus GH. 1 minus GH. In that case G becomes the entire thing, H becomes this value. Okay, so G becomes this entire thing, H is H2 by G5. Okay, note down this. మీకు టైం అయిపోయినట్టుంది, నెక్స్ట్ క్లాస్ కి ఉండాలి. ఓకే, so try to complete this one. So up to this part, okay, I have discussed. So finally you will get answer just by eliminating this one. Okay, G by 1 plus GH. So you will get the final answer like this. Okay, so tomorrow we'll continue the class. Try to solve that example. If you have any doubts, you can post in WhatsApp group. Okay, thank you.